Hey, I'm Mr. Williamson, and this video is about morphological adaptations. In the last video, we talked a little bit about adaptations. They're a trait that allows the organism to survive in an environment. Well, there's three types of adaptations. We're going to talk about one of them, and I'm going to go into that. Before we get started, make sure you're taking good notes. Again, if you haven't heard it enough times, Cornell or Outline, whatever scrambles your eggs, make sure you're doing it. Let's get started. Okay, real quick review. A real quick review. An adaptation is an inherited trait or set of traits that helps in the chances of survival and reproduction of an organism. It's something that allows the organism to survive in the environment. There are three types of adaptations: morphological, physiological, and behavioral. In this video, we're talking about the morphological ones. A morphological adaptation is a change in structure. For example, opposable thumbs. I'm going to talk about these. Hollow bones in birds, or changes in coloration. And in changes of coloration, we could be talking about cryptic, which you would call camouflage, or warning, or mimicry. We'll talk about all of those. The opposable thumb. The fact that you can do this makes you unique. Our ancestors could only do this. Okay, I used to, when we were in person, didn't do it anymore, haven't done it in a long time, and I'll tell you why. I used to challenge a student with 100 points of extra credit if they could go an entire day with their thumb taped to their hand like this. Okay, all they had to do is make it through the day like this. No one ever made it. I'll tell you why, because you got to go to the bathroom, and you can't undo your pants or put your shorts or pants or whatever on without your thumbs. You can't do it. It's impossible. No one's ever succeeded. But this is a morphological adaptation. It allows us to use tools. We can hold things, okay? Not like this, but we can actually hold things and manipulate them. Oops. We can use tools. Morphological adaptation. All right? Hollow bones in birds. If you want to fly, the lighter you are, the better off you are, because you don't have to use as much energy to keep yourself in the air. Well, bones are heavy. Matter of fact, one of the best weapons to prehistoric man was a femur bone of an animal. It's a huge club that just, can wreak havoc on your opponent. But birds don't want that. They want a light bone. So what they have is something kind of what's like in here. A network of bone that gives structure, the lattice of the bones, the structure of the bones, gives strength and structure to the bone, but they don't weigh as much because they're not solid, which is also why you don't give your dogs cooked chicken bones, because when you cook them, they become very brittle, and the bones can shatter and actually impale themselves through the neck of the dog. Just a lesson, my sister's a veterinarian. I know some of you may have big dogs and they can eat chicken like that, but you're taking a chance because it can seriously hurt them. All right? But hollow bones in birds, that's a morphological change because, well, it makes them lighter. Cryptic coloration, you guys would call it camouflage. Here's two pictures. Okay, on the left one, what do you see? Well, if you're good, you see a frog. It goes something like this. And its eyes are there, its nose is right there, its little hind leg kind of goes like this, hind leg kind of goes like that. There's a frog. Okay, in the middle of its back goes like that. That's a frog that is on the ground among the leaves, decaying leaves, and it looks very similar to, if I erase all of that, leaves. Over on the right side is an insect. It's not really a coloration, it's more of a body change completely. There are some walking sticks, 3 walking sticks. Where are they? One here, one along there, and the other one's here. All right? If you're a bird, human beings, we can take our time, we can think. If you're a bird or an animal that is trying to hunt and eat one of these things, you don't have a lot of time because there might be something trying to hunt and eat you, so you got to keep moving. Plus, if you stay in one place, you may not ever eat, so you have to be moving. You got to make quick decisions, kind of like the gizmo we did the other day with get the moths as quick as possible. Don't spend too much time on one tree because you gotta get as much as you can. You don't have time to go and looking for the thing. So as you're going along, these things tend to blend in. Camouflage, because you're not looking for them, it works. Where's the organism? What is the organism? Give you a moment. Okay, your moment's up. It's a deer. The hind legs actually are right here. There's the belly. The head is kind of up over here, and the back goes down like that. The coloration of the deer allows it to blend in. If you were a wolf or something that would eat the deer, you would have a hard time finding it. Okay, where's the organism? Give you a moment. Your moment's up. The bird is right there. All right, again, you're just trying to blend in. You do not have to be the fastest organism in the world. You just got to be faster than someone else. The zebra wakes up in the morning and says, to survive today, I do not have to be the fastest zebra. The lion wakes up in the morning and says, to survive today, I don't have to be faster than the fastest zebra. Both of them wake up and say, I just got to be faster than the slowest zebra. Long as you're not the slowest zebra, you're going to be okay. Long as the lion is faster than the slowest zebra, he's going to be okay. You don't have to be the fastest. You just need an advantage. If you're the one being hunted, you need to be invisible just a moment longer than the predator can see you, so you have a better chance to get away. If you can get the first step, you have a good chance of winning. All right? If you're the predator, if you can get one step closer to your prey, you got a good chance of capturing it. Again, obviously, you probably can see this one, the fish here, but then again, you're not the one who's doing the hunting. It's a fish, and fish are not that bright. So blending in with your background, here's, you're swimming along and seeing a fish, doesn't stand out and jump out at you right away. All right? Another thing, what is it? It's a frog, in case you don't see it. Okay? The head's up here, kind of goes around here. The tail end is underneath the leaf over there. There's a leg. There's another leg. Okay, and its eyes are right here, and the backbone goes down this way. All right? Frog. Again, you don't have to be invisible. You just got to be able to be let the organism, the hunter, the predator pass by you. All right. Again, you can see this, but this is an organism, a fox, that actually changes its coloration based on the seasons. In the fall, it grows white fur, so it blends in a little bit more with the snow. In the spring, it sheds the white fur and grows darker fur, so it blends in more with the background. Again, you don't need to be the fastest. You just got to get one step closer. Give yourself one step closer to advantage. All right. Here you have a tiger in some brush, some grass, some dried grass. Let me ask you, where is the tiger? Okay, obviously, I hope you can see the face here. All right. But where's the rest of the body? It's here. It's actually looking back over its shoulder. This is its rear end right in there, and its spine goes down that way. Why does that work? Because animals don't see like us. Animals see in black and white mostly. The bottom half is how we see. This is how people see. This is how most animals see. Black and white. So the stripes blending in and being bright orange color breaks up the outline of the tiger and makes it harder to see. There's also a thing called counter shading. Counter shading is where it's dark on top and light on the bottom. And it actually stems from our fish, evolution of fish. If you look down into the water column, into a deep water, it's dark. So the top of the fish is dark. If you're looking up through the water column, up towards the surface, it's light because the sunlight or a moonlight is up there, or even just starlight. Even in the darkest of nights, no moon, just stars, that starlight makes the surface brighter than the bottom, than looking down. When you're looking up, the light colored of the fish blends in with the surface, or makes it harder to see. Again, you don't need to be invisible, just got to be able to get that first step, that first little move. And that carried over into animals that we see today. If you notice, they're all usually dark on top and they're all light on the bottom. That is counter shading. All right. So that's cryptic coloration. That's coloration that's due to try to blend in, camouflage. Warning coloration is like the opposite. We do not want to blend in. We don't want camouflage. We want you to know we're there. We're so bad that you were like, yeah, look at me. Don't screw with me. I'm here. You don't want any part of this. This is a poison arrow frog. The mucus on the outside of the frog is poisonous. Just the mucus. The frog is like, here I am. Don't screw with me. Don't mess with me. You don't want any part of this. It's letting you know it's there. All right. This is a monarch butterfly, and you're thinking, well, what in the heck is a monarch butterfly? It's a butterfly. How can it be bad? Well, the monarch butterfly lays its eggs on a particular type of plant called the milkweed plant. Milkweed plant has actually a toxin in it. It's some kind of really bitter toxin that when the caterpillar eats the toxin, it incorporates that toxin into its body. And then when it develops in the butterfly, in a chrysalis, not a cocoon, remember that? Okay. In a chrysalis, and the butterfly now has that toxin in the body. So when a bird comes along and eats the butterfly, it throws up. That's why you came to school today, because you aren't going to get a chance to see birds puking any other place, just in my class in biology. So here's a blue jay that has eaten a monarch butterfly, and because of the toxins, it throws up. And it is actually associates, okay, I ate that butterfly and I threw up, I'm not going to eat any more of those butterflies. Now, if you're thinking about this, you might think, yeah, but the butterfly's still dead, Mr. Williamson. You're right. But it's not going to eat any more of them. So yes, that one butterfly is dead, but the rest of the species will not be eaten by that bird. It doesn't lose as many organisms because of the toxin. Loses some. We're willing to sacrifice a few for the needs of the many. What movie? This is not a monarch butterfly. This is a Viceroy butterfly. It looks like a monarch butterfly. And if you're a bird, you don't know the difference because you're a bird. There's a reason that we call people bird-brained. They don't have the world's biggest brain. So this is a Viceroy butterfly. It looks like the monarch butterfly. It's not poisonous. It doesn't have any of the toxins in its body. If the bird ate it, it would be fine. But it looks like the monarch. And it actually developed that way. They live in the same area. So once a bird's eaten a monarch butterfly, it's not going to eat any butterfly that looks like that. So real quickly, which butterfly are you going to eat? You're a bird. Quick. Come on. Which one are you going to eat? Which one was it? The right or left? Right or left? I'll tell you one more time. Right or left? Which one are you going to pick? Right or left? Right or left? Well, if you're a bird and you don't want to throw up, you eat this guy down here, because this guy up here is going to make you puke. How do I know? I'm put the slides together. I happen to also know that the thicker lines right here are the monarch butterfly. But if you didn't know, you could have, you'd be puking your little butterfly meal up. Warning coloration. This is a coral snake. Highly venomous. We have them in the United States, mostly in the southern areas, the far east, southeast, eastern states. I don't think there are any in California. And it does not have fangs like a rattlesnake. It has regular teeth like a normal snake, which face backwards. That way, when it grabs their prey, they don't escape. But it also has a venom. It's a neurovenom. It attacks the nervous system, and it's extreme. You get bit bad enough, it can kill you. You're going to be pretty screwed up if you get bit by one for over a year. I've read reports of people that get a minor bite and they're not good to go for a year or two. That's a coral snake. This is a king snake. Looks the same, but it's not. Completely harmless. You can this person is actually having it around their arm. Even So what's the difference between a coral snake and a king snake? Well, if red touches yellow, it kill a fellow, and if red touches black, venom lacks. So we're looking at if red touches yellow right here. I'll do that in another color for you. Right here, if red is touching yellow, it can kill you. If red is touching black, Doesn't kill you. Now, next time you see a snake like this, if you ever see one, I've never seen one, in the wild, I would not, quote me, I would just not pick it up. I wouldn't pick up, either one of these because I'm not going to bet on it. The thing about mimicry is that, first of all, the poisonous one, the monarch or the coral snake, had to develop the venom. So it evolved the venom and the poison and became dangerous. The king snake or the Viceroy butterfly, the one that is not dangerous, evolved to look like the dangerous one. So the dangerous one probably evolved first. The less dangerous one probably evolved second. Okay? And it only works if they live in the same area. If you're a Viceroy butterfly and you don't live anywhere near monarchs, then birds are going to eat you and they're not going to throw up. And they don't care. They're going to keep eating you. But if you live in a monarch butterfly population, then that bird's not going to figure it out. Same thing with the coral snake and the king snake. It only works if they live in the same area. That way the organisms that are preying on them or doing whatever can't figure it out. All right, so that's morphological changes. Changes where there's a change in the body. The examples I gave you were opposable thumb. Can do this, Birds' hollow bones makes them lighter when they fly. And then there's coloration. Cryptic coloration is like camouflage. It blends in with the background. Warning coloration is the exact opposite. You want to be seen because you know that no one wants to screw with you. You want them to know that don't mess with me. And then there's mimicry. You look like the warning coloration, but you're not. Okay, you're a poser. Pretty much the way it is. Hopefully you took good notes. If you have any questions, ask them in Edpuzzle or in the classroom. Good luck.